critical points. So key points on our pictures. What are these critical points? Basically, critical points are when the derivative is equal to 0, stationary points, or if it is undefined. Now, technically, the derivative equals 0, we don't say they're critical points because they've got their own name. They're stationary points. It's these undefined ones where we end up with vertical tangents, things like that. So let's draw some pictures. There's a graph, and as we know, well, that would be a maximum turning point. The derivative would be 0 there. We'd get a horizontal tangent if we were to draw it in. And down the bottom, we'd have a minimum one. And they're the ones we just talked about, stationary points. Okay, what about something like this? Right there is a stationary point as well. See, when a curve changes from concave down to concave up or vice versa, you will get what's called a point of inflection. We'll talk more about those later. But there's a special one called a horizontal point of inflection. So not only does it change concavity, but if I was to draw the tangent in, it would be horizontal as well. Now, not all inflection points are like that. That's for special ones. Horizontal point of inflection. The most common one you would have seen is the basic cubic. It has a horizontal point of inflection at x equals 0. Now, something like that, a parabola on its side. At that point there, we've got a vertical tangent. Well, a vertical tangent, you could think of as a slope of infinity, maybe something like that. You'll end up with 0 on the bottom of the fraction. So it's undefined. Now, if the derivative ends up being undefined, it's quite possible we might have a vertical tangent if that x value is in the domain. Well, if it's not in the domain, then there's no point there at all. But if it is in the domain, well, then quite possibly that's what we could see, a vertical tangent. Then we have this interesting shape. It's what we call a cusp. When it comes down, it still comes down to a minimum point, but it's not what we call smooth continuous. You see, if you approach that point from one side and looked at the slope of the tangent and approached it from the other, you get different answers. See, on the left-hand side, it's decreasing. On the right-hand side, it's increasing. So this is what we call a cusp. So that might be what you have if it's undefined. You might have this cusp. An absolute value curve would be another classic one like that when it comes down to that V shape. Basically, these sharp points, what we're talking about. It's undefined. The derivative is undefined at that point. It's not a smooth curve. 4C. Let's add that.